Congratulations on your purchase of the PETROGEN oxy-gasoline safety torch system. The PETROGEN system has been in use around the world for over 30 years. The U.S. Department of Energy recently selected the oxy-gasoline torch as an outstanding technology. DOE tests confirmed that the PETROGEN system provides greater economy and superior performance compared to acetylene torch systems. These tests also proved that the PETROGEN oxy-gasoline system is substantially safer than acetylene systems. The PETROGEN system has been tested by the U.S. Navy and approved for shipboard use. The U.S. Coast Guard has certified it for use on civilian vessels and offshore drill rigs. The system is listed by Underwriters Laboratories. With your purchase of the PETROGEN oxy-gasoline torch system, you're joining thousands of users who are moving away from the dangers and expense of old-fashioned acetylene to the safer, more economical, and better performing oxy-gasoline standard of cutting. And your training time is minimized because the PETROGEN system in many ways operates much like the acetylene system. In this training video, we will show you the safety advantages of the PETROGEN oxy-gasoline system over old-fashioned acetylene, how to set up the system, and the startup procedures that differ from acetylene. Some examples of how the PETROGEN torch outperforms acetylene with some time-saving techniques and benefits that acetylene can't offer, and an overview of the general maintenance of the PETROGEN system. Remember to look in your PETROGEN reference manual for additional information on system setup, startup, use, maintenance, and troubleshooting techniques.
The PETROGEN oxy-gasoline cutting torch system is the safest oxy-fuel system in the world, and the reason is gasoline. We use pure liquid gasoline available at any gasoline station. Now, at first thought, you might believe that the gasoline is dangerous in your cutting torch system, but you've got 20 gallons of gasoline in every car on the freeway. How would you feel if there were an acetylene tank in every one of those cars? So cutting steel with gasoline is a very safe procedure because the gasoline as a liquid will not even burn. And we keep the gasoline liquid all the way from the tank, right through the hose, all the way through the torch and into the cutting tip. The gasoline vaporizes in the cutting tip. Because the gasoline is liquid, you cannot backflash the PETROGEN torch up the fuel line. Totally impossible. I'm going to demonstrate that by lighting up and putting the head, burying it in a box of sand. Now, the worst that could happen is that the flame will go out. Most likely it won't. It will keep right on burning. Besides eliminating the hazard of backflashes up the fuel line, the PETROGEN system also eliminates the second most important reason for danger in the acetylene and propane systems, and that is undetected leaks. In the PETROGEN system, because gasoline is liquid, the slightest leak will develop a wet spot. You can see it, you know where it is, you can fix it. If you forget to turn the torch off and lay it on the table on the ground, you'll see a wet spot. Someone else will see it, you can fix it and turn it off. This is not danger, this is safety. The other systems could leak their fuel into the air undetected, could gather and ignite on a spark. Another advantage of gasoline is its vaporization in the tip. And as you know, vaporization is a cooling process. When the gasoline evaporates in the tip, it turns the tip into a refrigerator. The tip runs cool, the head runs cool. I'm going to demonstrate that. The larger the tip, the cooler it runs because there's more gasoline vaporizing. Another advantage for PETROGEN, At the tip is the fact that the sparks that the cut generates are lightweight and very little heat in them, much less of a fire starting hazard. And the reason is that gasoline is 100% oxidizing. All the sparks that come out of the cut are burnt out slag. There is no molten steel. With acetylene, 30% of those sparks are molten steel and hazardous. The PETROGEN tank has many safety features incorporated in it. The most useful one and most important is the fact that in this outlet valve, this is where you hook up the gasoline hose, in this outlet valve inside the tank body is a floating brass ball that serves as a fast flow check valve. If the hose out here gets ruptured or a heavy leak, the flow of the gasoline will pick up that ball and seat it upwards and shut off the flow. There's also a check valve underneath the pressure gauge in case the pressure gauge gets knocked off. In the filler cap, there is a pressure relief valve that opens up at about 35 psi. So if this tank gets caught in someone else's fire, the gasoline inside will boil, the vapors will come out and add to the fire, but nothing will get back into the tank. When the fire is extinguished, you'll find gasoline still in the tank. And another safety feature is the lightweight tank. This tank, filled with 2.5 gallons of gasoline, weighs 30 pounds, and that's the exact cutting equivalent of a large acetylene tank that holds 250 cubic feet of acetylene and also weighs 250 pounds. So you're about 200 pounds lighter moving this thing around at your job site. This means a lot less aches and pains. The safety of this system has been attested by Underwriters Laboratories, by the United States Department of Energy, by the United States Navy, the United States Coast Guard, and other testing bodies around the world.
As you unpack and assemble your PETROGEN system, you'll find these standard system components. The torch with cutting tips, parts kit, tool kit, and spark striker. Oxygen hose assembly, fuel hose assembly, and the fuel tank, a 2.5 gallon gasoline tank. To use the system, you will also need a standard oxygen tank and an oxygen regulator. During this video, we'll be showing the system being used on the optional PETROGEN hand cart. Take the gas tank to a gas station and fill it with 2.5 gallons of any grade gasoline. You should fill your tank only at the gas station. Contaminants, such as oil from dirty funnels or old gas cans, will not cause safety issues, but can cause the flame to burn yellow and can reduce performance. There is no regulator on the fuel tank. Instead, the PETROGEN system has a built-in hand pump and pressure gauge on the tank. Pump up the tank pressure to 20 psi using the hand pump. As we mentioned in the safety section, you will notice that there is no backflash arrestor needed on the fuel line. As with all torch systems, we do recommend the use of a backflash arrestor on the oxygen line, and we will demonstrate use of the torch with this option installed. Connect the red and green hoses to the torch. Connect the other end of the green hose to the oxygen regulator. Connect the other end of the red hose to the gas tank valve. Now that all your lines are connected, follow standard safety practice by standing to one side of the regulator and open the bottle valve slowly and fully. Now, open the gasoline valve very slowly, about 2 turns. Remember that the tank has a fast flow check valve, and if you open the gasoline valve too quickly, this can cause the check valve to shut off the fuel flow. If the check valve shuts off, close the fuel valve at the top of the tank and tap the tank on the ground a few times. This will reopen the check valve. Once the hose is pressurized, open the gasoline valve fully. There is now liquid gasoline running from the tank through the hoses to the tip of the torch head. The torch is now ready to light. Because the PETROGEN system uses liquid fuel, its startup process is quite different from gas fuel torches like acetylene and propane. First, let's show you a typical startup procedure. Then we'll show you each step in detail. Here is the startup procedure. It's quick and easy. Yes, the user is touching the tip to metal, which is a completely safe process since there is no possibility of fuel line backflash. The torch is now lit and ready to use. This startup procedure is actually two processes: lighting the torch and the preheat flame adjustment, which adjusts the flame for cutting. These two procedures happen quickly and in succession. Let's watch and identify each process. This is lighting the torch. And this is the preheat flame adjustment. It's an easy, quick procedure. Now we'll show you in detail each of these two processes. Before you light the torch, you'll need to select a tip size and set the secondary gauge on the oxygen regulator to the desired pressure. You'll find a handy chart in your reference manual and on the side of the PETROGEN tank. The first step in lighting the torch is to open the preheat oxygen valve. Open the preheat oxygen valve about 3/4 of a turn. Next, open the torch gasoline valve at the butt of the torch and adjust the valve until a light mist is visible. As with any torch, it is also very important to depress the cutting lever before lighting the torch to purge oxygen lines of any fuel that might be present. Hold the cutting lever down for at least 5 seconds. With the gasoline mist transparent but still lightly visible, strike a spark very close to the tip to ignite the mixture. Don't hold the sparker for too long in the mist or it will get wet and will not light. On first lighting the torch with your new unit, you may need to relight the torch about 3 times until the gasoline flow is continuous. This is because, unlike the acetylene gas hose, the red gasoline hose must fill with liquid. Because the hose was empty when gasoline first entered, there will be air pockets present until the hose is bled. When an air pocket reaches the tip, the flame may go out. In just a fraction of a second, the gasoline flow resumes. This situation is only present when hoses have been detached, allowing air into the hoses. You will not have to bleed the hose again as long as the hose remains connected. So the flame may go out about 3 times until the hose is bled, and then will stay lit. A brand new gasoline hose contains a manufacturing residue that may cause the flame to burn yellow. After about 5 minutes of use, this residue washes completely out of the standard 20-foot long gasoline hose, and the flame becomes normal. Longer hoses will take a longer time to wash out this residue. It is now time to adjust the flame. Gasoline flame adjustment is a little different than acetylene flame adjustment. When the PETROGEN torch is first lit, there is more yellow in the flame compared with the acetylene flame. When the torch tip is cold, all the gasoline is not vaporizing inside the tip. To warm the tip, it is necessary to press the tip against the steel for about 5 seconds. This warms the tip sufficiently to vaporize all the gasoline passing through. Of course, you'd never press the tip this way with an acetylene system for fear of backflash. But remember, because the PETROGEN system uses liquid fuel, there is no possibility of backflash. After the tip has been warmed for a few seconds, the final flame adjustment can be made. The adjusted PETROGEN flame is different from the acetylene flame. The adjusted PETROGEN flame has an inner dark blue core about 3/16 of an inch long, a short and barely visible flame umbrella surrounding the core at about 30 degrees, and a bit of orange at the end of the secondary flame. If the flame looks like an acetylene flame, it is too lean. Open the gasoline valve a little more. Most PETROGEN tip sizes work well with the inner preheat flame 3/16 of an inch long. But smaller sizes, 0 and 1, work better with the preheat flame only 1/8 inch long. See your reference manual for specifics on this. Another test for a properly adjusted flame is to press the tip to steel and get an orange sunburst with the rays 2 to 3 inches long. There will be a steady, mild roar. Let's watch the entire startup process once more. When you're lighting the torch, you can follow the step-by-step lighting guide in your reference manual. You are now ready to cut steel with your PETROGEN torch system. When you're finished cutting, use the following process to shut down the torch. 1. Close the torch gasoline valve. 2. Close the torch preheat oxygen valve. 3. Now that the torch is shut down, check to make sure the tank filler cap is closed and the tank shutoff valve is closed. Leave the tank, torch, and hose connected for storage. The PETROGEN torch brings steel to ignition faster than acetylene. This is not due to its 5200 degree temperature, but to gasoline's very high rate of heat release. More heat is poured into the steel faster, bringing steel to the melting point faster. You will be pleased at how quickly you can start your actual cutting. It is not necessary to warm a thick piece of steel before cutting with PETROGEN. PETROGEN can always cut steel from a cold start. PETROGEN cuts steel up to 4 times faster than acetylene, from 20% faster at 1 inch to 400% faster at 10 to 12 inches. Penetration is accomplished by a 100% oxidizing flame and a vapor 4 times heavier than acetylene. Adjust your cutting speed to take full advantage of PETROGEN's power. Acetylene torches are thwarted by air gaps, layers, and surface contamination. PETROGEN's oxy-gasoline flame jumps air gaps and easily cuts through multiple layers, surface dirt, rust, and paint. PETROGEN also handles concrete-backed steel. PETROGEN safely and quickly punches holes up to 10 inches deep. Acetylene's maximum straight hole punch is a mere 3 inches, with deeper holes requiring trenching. The PETROGEN torch allows you to do many jobs you could never do with acetylene. Acetylene cuts are often left with adhesions due to premature cooling of the molten steel. PETROGEN cuts cleanly on the first pass because of its total oxidation of the steel. The gasoline torch only has to cut the steel once. A PETROGEN cut never requires grinding in preparation for welding. With PETROGEN, all tip sizes have relatively large coupling distances, with size number 8 able to cut steel from a distance of 5 inches. This allows you to stay away from blowbacks, cut around obstacles, and lengthen the life of your torch tips. PETROGEN can make these powerful cuts because the oxygen jet is surrounded by burning fuel all the way down the jet. It is like cutting with the edge of a long hot knife. Heat goes down with the cutting jet. Unlike acetylene, it is not necessary to rely solely on burning steel from the top to carry additional heat down to the depths of the cut.
These are the parts that come with your tool kit and your parts kit. And I'll show you what each one of these are for. These three, the tip drill, the tip brush, and the tip reamer, maintain the cutting tip. This ramp is used to put on an O-ring in a high-pressure oxygen valve. This jack screw is used to take the mixer out of the torch head. This hex wrench is used to take out the hose connectors at the bottom, at the butt of the torch. And this is a packing nut wrench to tighten the packing nuts and help you take out the high pressure valve. To begin with, the packing nut wrench is used to adjust the two packing nuts on the torch. There's one right here, right underneath the hand wheel for the gasoline valve, and another one, there's a packing nut right underneath the hand wheel for the preheat oxygen valve. Adjust those packing nuts so they're tight enough to stop any gasoline leak, but tight or loose enough to suit your touch, how you like it. This jack screw is used to take out the mixer, which is inside the torch head underneath the tip. The tip sits on the mixer. Occasionally you might have to take the mixer out in order to replace O-rings or this sintered bronze wick. You insert the jack screw into the mixer. When it exits from the bottom, it pushes against the torch head and the mixer pops out. The hex wrench is used to take out these hose connectors in case you damage the threads and you need to put in a new hose connector. They fit inside here and you just take it out with a counterclock motion. The tank also has a packing nut here at the shutoff valve. We don't have a tool for that, but take any adjustable wrench and adjust that packing nut in the same way. Tight enough to stop any leaks and loose enough to suit how you like it to feel. The cutting tip is two pieces. They both have to occasionally be maintained because of carbon buildup. You'll never get any dirt inside the cutting tip. What you'll get is carbon, like on your carburetor. If you run too hot, too long, and too rich, you might have to take the carbon off. This is the tip reamer, which takes the carbon out of an area in below the tube that's pressed into the shell. The tip brush is used to brush off the carbon that might accumulate on the flutes here. The tip drill set is something that you'll never have to use with the PETROGEN system, and the reason we put it in there is because all our customers expect to see it because of their experience with acetylene and propane. But just so you know what's in there, these are the drills. They're sized to fit each of our successive tip sizes, and they fit inside the cutting jet in order to clear it of any obstruction. But you'll never have an obstruction with the PETROGEN system. The seating of the tip is very important. There's not too much you can do about it. We manufacture to very close tolerances at the factory, and it fits into the seats in the mixer, like that. If your torch gets to leak or to pop continuously, you have a seating problem. And it's probably in the surfaces at the bottom of the tip, because the tip is made out of brass and the mixers are made out of durons, which is a harder metal. So if you have a continually popping torch, you've got a leak in the passageway in this inner seat. There's an inner seat and an outer seat. If the leak is in the inner seat, some of the fuel will get into the jet hole and pop as it exits. If the leak is in the outer seat, some fuel will come out outside and come outside the tip nut, and you'll see some flame. If that happens, just use another tip, change tips, If you can, you might try some sandpaper to eliminate some of the irregularities or change the fit of the seating. There are detailed instructions in the reference manual. There's one item of maintenance that you'll probably need to pull about once a year, and that is the O-ring that's inside this high-pressure valve. When you take out the high-pressure valve, take it apart using the packing nut wrench and a screwdriver, and one will hold it against the other. And when it's apart, in that high-pressure valve is the valve stem, and in that valve stem there's an O-ring. If that O-ring is broken, you'll get a steady flow of oxygen from the oxygen bottle right through the torch and coming right out of the tip, even with all your valves closed. If that happens, this O-ring is broken and you have to put in a new one. Take it out of the high-pressure valve. Use this ramp built for the job, and also in your parts kit there will be some extra O-rings of that size, and you roll it up the ramp. And that's it. You've got a new O-ring. Put it back together the same way you took it apart. And that's really all there is to the maintenance of the PETROGEN system. Your reference manual is a complete source of what might happen to your torch, how to recognize it, and how to fix it. The reference manual can be a great assistance to you, and of course we at the factory are always ready to help you with any of your problems.
The PETROGEN oxy-gasoline torch system is replacing acetylene around the world. Users are drawn to its safety, unequaled performance, and tremendous fuel economy. Once you have adjusted to the few easy-to-learn differences in the operation of the PETROGEN system, all these important benefits will be yours. Let's briefly go over lighting the torch and preheat flame adjustment once more. First, open the preheat oxygen valve. Next, open the torch gasoline valve and adjust until a light mist is present. Next, depress the cutting lever to purge oxygen lines of any fuel. Next, with the gasoline mist transparent but visible, strike a spark close to the tip to ignite. The preheat flame adjustment. Hold the torch tip to the steel for about 5 seconds to warm the tip. Now that the tip is warm, make the final adjustment so that the flame has an inner dark blue core 3/16 of an inch long, a short and barely visible flame umbrella surrounding the core at about 30 degrees, and a bit of orange at the end of the secondary flame. With these basic differences in mind, you should be able to master the PETROGEN system with a minimum of training time, giving you the safety, economy, and outstanding performance you've seen here.